Okay, I know exactly what you're feeling right now. The exam is tomorrow, the stakes are incredibly high, and you're staring down the barrel of the Infosys Specialist Programmer and Digital Specialist Engineer coding round. You might be feeling a little anxious, and hey, that is completely valid. But take a deep breath. You are in the right place. Welcome to This Explainer. I'm your host, and tonight, consider me your personal mentor. We're going to take all that pre-exam anxiety and channel it into sheer, focused execution. Let's dive right in and get you ready to absolutely conquer this thing. So, the magic number for tomorrow? It's 3. You are going to face 3 questions, and you will have exactly 3 hours to solve them. Now, hearing that the clock is ticking for 3 whole hours on just 3 problems, yeah, it sounds intimidating. It tells you right away these aren't your basic, everyday coding puzzles. But here's the secret. Having a solid, predictable strategy going in is your ultimate weapon. We've got a rock-solid game plan for this explainer. We're going to break down the exact exam format so there are 0 surprises, map out the core questions you need to know, and then do a deep dive into the big 3, the vacation problem, XOR sum, and the notorious mountain array. Finally, we'll wrap up with the exact mindset you need to win.
All right, let's jump straight into the format. You absolutely cannot walk into this battlefield blind tomorrow. You need to know exactly how the points are distributed so you can ruthlessly prioritize your time.
The test is strictly divided into 3 tiers. Question 1, that's your easy level, worth 20 marks, usually focusing on standard data structures. Then you hit question 2, the medium level. That one is worth 30 marks and almost always tests your ability to implement a greedy algorithm. Then there's question 3, the hard level. This is the 50-mark behemoth, and you can bet your bottom dollar it'll be based on dynamic programming. So realize this. It's not a random assortment of questions. It's a highly structured test, and we are going to exploit that structure. Now, what about the actual questions they pull from? Let's talk pattern recognition. When you look at massive lists of past coding problems, it's so easy to just panic. But top candidates, they don't panic. They recognize the patterns. We've grouped the 13 core questions from the PrepInsta dataset to instantly reduce your cognitive load. Look at how they break down. Under greedy algorithms, you've got monster defeat, vacation, gym, and heroes versus villains. Dynamic programming covers divisible arrays, binary string, and mountain array. For bit manipulation, expect LIS bitwise, XOR subset, and XOR sum. And finally, math and binary search cover min-base and road digging, while string manipulation is just string cutting. You aren't studying 13 random problems tonight. You are mastering 5 core patterns. Okay, let's zoom in on our first high-yield target, the vacation problem. This is a classic greedy archetype, and mastering it is an absolute must for grabbing that 30-mark slide. The premise sounds simple enough, right? Andy wants a vacation, he's got a total of N days, but he has M obligations scheduled on specific days. He's allowed to cancel at most K of these obligations. The goal? Maximize his consecutive vacation days. That's it. Cut through the story fluff, and the objective is basically just finding the longest contiguous block of free days by strategically removing a set number of blockers. To put that into perspective, say Andy has a 10-day window, and he can cancel 2 of his obligations. Boom, the maximum consecutive free days he can get is 5. But how does your code figure that out efficiently without timing out by checking every single possible combination? Enter the sliding window approach. This is your actionable mental model. First, you map out exactly which days have obligations. Then, you create a virtual window over the array of days. You just keep expanding the right side of this window to include more days. Every time you hit an obligation, you count it against your limit of K. If you go over K, no problem, you just shrink the window from the left until you're back under the limit. The maximum size this window reaches is your answer. It's clean, it's fast, and it secures you those 30 marks. Moving right along, let's tackle a topic that terrifies a lot of candidates, bit manipulation, specifically the XOR sum problem. But honestly, once you see the trick, it's incredibly satisfying to solve. Here's the mission. You're given an array of numbers and a maximum limit, K. You need to find a single integer x, somewhere between 0 and K, that maximizes a massive XOR sum across the entire array. I know the math notation looks intense, but do not let it psych you out. Check this out. You have a tiny array 7, 4, 0, and 3. Your K limit is 9. The maximum achievable XOR sum you can squeeze out of that is actually a whopping 46. You get that by picking 8 for X. But obviously, you can't just randomly guess your way to 8. The secret trick here? Never look at the numbers as a whole. You've got to look at them vertically, bit by bit. Convert everything to binary. Then, for each bit position, count how many numbers in the array have a 1 there. Finally, greedily construct your answer X from the most significant bit down to the least. If setting a bit to 1 makes your final sum bigger and keeps you under K, you do it. You build the answer one single bit at a time. It's actually just a greedy algorithm wearing a bitwise disguise. All right, take a breath, because we are facing the final boss now, the mountain array problem. This is dynamic programming, the 50-mark challenge that separates the pack. The condition here is super specific. You have to change an array so both extreme ends are exactly equal, and from the ends moving inward, the numbers strictly increase until they hit a single peak in the middle, like a mountain. You need to find the absolute minimum number of changes to make that shape happen. So if you get a raw array of 1, 2, 3, 4, 5, it takes a minimum of 2 changes to turn that into a valid mountain. Why? Because the ends don't match, and there's no downward slope on the right. You'd have to tweak it to something like 1, 2, 3, 2, 1. And here is your DP blueprint. Don't go trying to change elements randomly. Reframe the whole problem. Use dynamic programming to find the longest existing subsequence in the array that already forms a valid mountain. Once your algorithm finds that longest valid sequence hiding in there, you just subtract its length from the total number of elements. Boom, the difference is your minimum changes required. Find the pattern that works first, then fix the rest. That is classic DP. Okay, let's step away from the code for a second. We've covered the patterns, the deep dives, the algorithms. Now, we need to talk about the absolute most important variable in that room tomorrow, your mindset. I want you to burn this into your brain. Panic is your only real enemy in that room. When that timer starts, your heart rate is going to spike. Do not, I repeat, do not look at the 50-mark DP problem first. Grab that easy 20 marker, secure your baseline, and just breathe. Prove to yourself that you belong there. You need a ruthless time management strategy. Step 1, knock out those easy 20 marks in the first 45 minutes. Step 2, attack the medium greedy problem. You know to look for those sliding windows now. Secure those 30 marks. Step 3, spend whatever time you have left grinding out the 50-mark DP problem. Even if you only pass partial test cases there, combining that with a perfect score on the first 2 puts you miles ahead of the competition. So here is your final checklist for tonight. Review your greedy and DP patterns, do a quick refresher on those XOR rules, nail down the sliding window technique, and hey, after the dust settles and you crush this thing tomorrow, make sure you star our GitHub repo for code references, connect with us on LinkedIn, and subscribe to Prep Insta Prime to keep that momentum going. You've put in the work, you understand the structure of the test inside and out, you've mapped the patterns, and you have the mental models for the hardest algorithms they can possibly throw at you. So the only question left to ask is this: are you ready to beat the clock and conquer the Infosys coding run tomorrow? I know for a fact you are. Get some rest, stay sharp, and go crush that exam. Good luck.